Our final piece to rational expressions before we go ahead and quiz for chapter 8 is on adding and subtracting. Now, if you recall back to adding and subtracting fractions, we need to first actually factor if necessary. In the case of example A, we don't have any factoring to do. Our step 2 then is to multiply each fraction by either the opposite denominator or the missing denominator piece. In our case, because remember, adding and subtracting fractions, you need like terms on the bottom. You need common denominator. In our case, we already have common denominators, so we can move on to step 3, and which might be to distribute or FOIL the numerators if you have that common denominator. And then step 4, which I'll get out here for you, it's going to be add and subtract numerators. If subtract, make sure you distribute the negative through by combining like terms. And finally is going to be to simplify your answer if possible. So if we go back up here, remember, if we are adding these, you add the numerators only, so we have, it's like saying 5x plus 2x all over 3x squared. Well, 5x plus 2x is equal to 7x, and we have 7x over 3x squared. We can't simplify the numbers, but I do see that I can cancel this x with one of these, so that makes my final answer 7 over 3x. Now if we look at one that has a binomial to it, I already have common denominators and they're already factored. This one is subtraction this time. So I'm going to say this is x squared minus 9 over x minus 3. Well, I see that when I take x squared minus 9, I can take and factor this. It's a difference of squares, which gives me x plus 3 times x minus 3. And this is over x minus 3. I can then cancel the x minus 3's, which leaves me with the final answer of x plus 3. Moving on to one that doesn't have common denominators. The first thing I want to do is factor. So when I rewrite this, I see that I have x over x minus 2, which is already factored, plus negative 8 on top, and x squared minus 4 is a difference of squares again. So this is x plus 2 times x minus 2. Then when I look at this, I say, well, to get common denominators, this rational expression here is missing an x plus 2. So just like you would with the complex conjugate, we're going to multiply both top and bottom by x plus 2. And we multiply top and bottom because x divided plus 2 divided by x plus 2 is 1. So now we can go through and I'm going to distribute, we're going to FOIL this out on the top so that way I have a reduced expression. So I have here x squared plus 2x, and that is also plus a negative 8 or minus 8, and that is over x plus 2, x minus 2. I got the x plus 2 times x minus 2 because I have that here and here. I got the x squared plus 2x because I went and distributed this x in here, and then the minus 8 comes from right here. The next thing I actually want to do is refactor this out to see if there's anything I can cancel. And I see I need two numbers that multiply to negative 8 and add to positive 2. And I know that that'll give me x plus 4, x minus 2. And that's over x plus 2, x minus 2. And then I see that I have x minus 2's in common that I can cancel, which leaves me with a final answer of x plus 4 over x plus 2. Let's now look at the last example, which is subtraction. I don't have anything that I can factor, but I do see that my common denominator is going to be both this times this. So that means that this first fraction is missing the 2x plus 5. And over here, that means that this rational expression is missing the 3x minus 1. Now, I'm going to leave the denominators as 2x plus 5 times 3x minus 1 but I'm going to distribute the 6x in for here, which will give me 12x squared plus 30x. And over here, distribute the 4x in, giving me 12x squared minus 4x. So now I want to look at this as being here. So when I combine all this into one fraction, I have 12x squared plus 30x minus the quantity 12x squared minus 4x. And that's all over 2x plus 5 times 3x minus 1. So now I can go ahead and distribute this negative in, which means that on top I'm going to have 12x squared plus 30x minus 12x squared plus 4x, because it's minus a negative, and this is all over 2x plus 5 times 3x minus 1. So now I see that 12x squareds are going to cancel, and I have 30x plus 4x, which is 34x, over 2x plus 5 times 30x minus 1. And there's nothing I can cancel, because there, as you can see, there's nothing in common, which means that this is my final solution.